My name is Clemens Fastas, and this is Subscribe. Welcome. Thank you for tuning in. I'm Clemens, and I work at Microsoft on the real-time intelligence team, which is also the Azure messaging team. Our group owns the core messaging fabric of Azure: Event Hubs, Service Bus, Event Grids, Stream Analytics, and also the event stream capabilities within Microsoft Fabric. And we also own the Azure Relay, which I'm going to talk about in a moment. As the architect for this portfolio, I focus on the general direction and strategy and standards. Standards world have been deeply involved in the development of MQP, MQTT, CloudEvents, and most recently registry and JSON structure. And I've also worked on industrial things like OPC UA. About 12 years ago or so, I did a video blog centered on IoT. And I've decided to revive that format. So moving forward, I'll be publishing focused about 10-minute clips, 15-minute clips that are, that you can go and to listen on the commute to, on specific architectural topics, and also building some foundational knowledge that you can go and look up. We'll talk about Service Bus internals, we'll talk about Event Hubs internals, we'll focus on patterns, on best practices. However, today, in this episode, this is not about the products, it's about the journey, how we got there, because this coming Sunday, on February 1st, marks my 20th anniversary at Microsoft. Before joining Microsoft, I co-owned a company called Nutelligence, where we focused on .NET developer training. And before that, I worked at a financial services consulting company or a software company. At Nutelligence, we produced the .NET crash course. There's a copy here. One of the first deep dives into the framework, and we also educated the worldwide Microsoft field. I was very involved in the web services community and Complus community back in the day. And then eventually that led me to being hired by Microsoft into Redmond. So 2006, I joined the Windows Communication Foundation team, fabulous book by Yuval Lovi, as the community manager, because I've been an MVP and regional director before that. And so I helped landing kind of WCF as part of .NET 3 with the community folks. As we had then finished Windows Communication Foundation for Windows Vista, the team was planning to build a very comprehensive application server that proved a little bit too complicated. There's still bits and pieces of this. And one of the bits and pieces of that was a little incubation within the WCF team that was trying to solve a particular problem. I have web services now, in this new world, and this is all before the cloud, and how do we make those talk to each other through firewalls? So that led to the relay. We built a service that would allow this by having a rendezvous point in the cloud. And we released the prototype in 2006, and I joined that team in February 2007. And you can draw a straight line from today's Azure Relay back to that incubation. And some of the WCF-based client code still in the client today that we have canceled or are retiring, is still dating back to these early starts. From 2007 to 2010, the primary work was actually building Azure itself. It became commercially available on February 1st, 2010. And during that time of like 2.5 years, we not only built features, but we had to build the precursors of pretty much everything. We built the access control service, a predecessor to Azure AD, an early workflow service. We built internal workflows because the biggest challenges was provisioning, right? In 2008, Microsoft didn't have a global pipeline for billing or automated tenant provisioning for application services. So our small team, working alongside the Red Dog team over in Building 109, the SQL team over, I think, in Building 36, built the groundwork for all of this. We had to figure out how to automate DNS provisioning, allocate storage, allocate compute, do service isolation. And then once we've done this for our own services, we eventually taught the rest of the company how to build and provision services, and services like cache and websites and all these things using the capabilities, the cloud capabilities that we pioneered. So we're kind of plank holders of the Azure cloud. In the initial version of Service Bus, we utilized a fairly sophisticated state replication technology called the Service Bus overlay that ensured that even with data in memory, because our first queues were memory backed, you wouldn't lose it if a node failed. That technology eventually evolved into Service Fabric, which still manages the clusters for almost all of the Microsoft stateful services. So we've been not building that service, but we've been some of the first users of it. We later merged with the MSNQ team, who were rebuilding their platform on SQL Server Express and were exploring AMQP. While they never really shipped on SQL Server Express, Service Bus became kind of the next version of MSNQ. So that integration brought the queues and topics that you use today. The next major shift was driven by Halo. The Halo game had been using Service Bus, has been starting to use Service Bus for game telemetry, but the queues weren't really designed for that massive consumer scale ingress. So we looked at LinkedIn's Kafka project, but in those early days that didn't meet our stability or AMQP requirements, so we built event hubs ourselves. As we scaled event hubs, we then realized that there was a massive gap in the area of mobile engagement for large events like the Olympics. How do you notify millions of people at the same time about something? So we wanted to build a way to push messages, not just between servers, but really to millions of mobile devices across different platforms in minimal time. And that led to Azure Notification Hubs. Notification Hubs still provides a cross-platform scaled-out push engine, and it allows you to send notifications to iOS and Android and Windows using a single API, and it completely abstracts the complexities of platform-specific registries. That was our first major foray into massive scale push beyond the backend, and that still exists in the mobile SDKs for Azure, and no longer in our team. All of that then naturally kind of seeped into the Internet of Things. We saw devices in the field, like cars and trucks, but also smart meters, industrial equipment, needing a way to attach to the cloud and either do bidirectional communication or send telemetry. That led to us building IoT Hub. IoT Hub is essentially an event hub with specialized gateway for bidirectional communication, supporting AMQP and MQTT at the edge. We initially clashed with the MQTT community a bit over protocol specifics, especially in 3.1.1. But then eventually we joined forces, made a significant amount of contributions to MQTT 5.0, where I was not at the table, but kind of quarterbacking the effort, and eventually integrated into IoT Hub. And by now we have a full MQTT broker as part of Event Grid that speaks MQTT 3.1.1 and 5. Once the cloud grew, we then needed a way to handle reactive programming, knowing when a file was uploaded or storage or a resource was created. And then we wanted to kind of have notifications being sent. So we needed to have an event broker. The problem was that every service had different event formats, and that inside of the cloud, inside of our own cloud, but Google had the same problem, AWS had the same problem. And so we all sat together and collaborated with 40 more companies in the CNCF to create a standard called CNCF CloudEvents that I wrote a good chunk of. This standard is how an event looks, and across the industry, and also has common bindings. And Azure Event Grid is our implementation, effectively, of the standard. It's using CloudEvents as its primary event model, and it's a push-pull broker for the Azure cloud, and you can also use it beyond that. Recently, our team then moved from the application platform world into the data world. Streaming data is now the backbone of AI and machine learning, and of data in general, and that led us to Microsoft Fabric. And in Fabric, we provide real-time intelligence, and inside of that, event streams. And you can think of this as the integration of event hubs and stream analytics and Event Grid into a single opinionated experience. In Azure, we give you the building blocks. In Fabric, we wire them up for you to remove friction and enable non-developers even to build real-time pipelines. I'm currently focused on two forward-looking projects, JSON Structure and X-Registry. JSON Structure is a data description language that provides a proper type system for JSON without the overhead and the complexity really of JSON schema. It looks a lot like JSON schema, but it has a lot tighter rules. And the hope is that that can be something that is helpful for folks who want to build data definitions for JSON and also for applications in general. And X-Registry is an CNCF project that provides an extensible metadata registry that allows you to define the hierarchy of schemas and message definitions and endpoints for messaging, but also allows you to go and store, manage metadata in general. But the goal is to create a clear interface for event-driven architectures in the form of metadata. So you'll be hearing about this more in this series. It's been 20 years on the same team, practically 19. And I'm still enjoying it a lot. I'm having a lot of fun. We have very significant plans for the future of streaming, for the future of messaging. I think we're building interesting stuff. And starting week after next, still need to have a little bit of time to get everything in shape. I'll be back here on this channel with technical deep dives, best practices and demos. And I hope that you will subscribe.